Hi guys, in this video I will show you guys how to calculate the area under the curve, whether we use left endpoint or right endpoint. So we have this problem right here. The graph of f of x equals x squared for x is greater than or equal to 0, and notice that the interval 1 is less than or equal to x less than or equal to 3 and is divided into 4 equal subintervals. So first, in order to either you calculate the left endpoint or right endpoint, you need to divide it based on the amount of subintervals the problem give you first. So in this problem, it's give you 4 equal subintervals. So therefore, I'm a visual learner, so I will start with the number line first. Okay, so on the number line, I start with 1 and then 3. So then I divide it into 4 equal parts. Okay, so now on the number line I can figure it out. Between 1 and 3 will be 2, between 1 and 2 will be 1.5, between 2 and 3 will be 2.5. Alright, so then that means each of the subinterval right here is 0.5. Okay, and then I can show you how to do it algebraically too. So then in order to find a subinterval algebraically, we can do 3 minus 1 over 4, which is the number of equal subintervals you want to divide it. So then you have 2 divided by 4, which is 0.5. So same thing. Alright. So now let's start with the right endpoint. Okay, so we have right endpoint. Okay, so now I will zoom it in here. Okay, and we just focus on right endpoint. So this is f of x equals x squared, right? So then now right endpoint on my graph, I already graph it for x squared, and on my graph I will see 1 to 3. So 1 right here and 3 right here. And I divide it into 4 equal parts. So just do the same like what we did earlier. Okay. So then if we want to calculate the area of under the curve, we will use the rectangle to do it. So then we will draw the rectangle, and since we use the right endpoint, so that means this one I draw it up, and this one. So now I will have the right endpoint is right here. Okay, that's my first right endpoint. And then next I'll draw the next one. So right, that, and my right endpoint is right here. And then next, okay, I want to show you guys that they share the side. And right endpoint is right here. And then next one, I have this. All the way up here then. My right endpoint. Okay, so that's how we use right endpoint. And earlier we also know this is 1.5, this is 2.5, and the increment for each subinterval is 0.5. Alright, so if you use right endpoint, that means you have to find the areas of the blue rectangle, green rectangle, red rectangle, black rectangle, and add all of them up. So in order to find the area of blue rectangle, we will have length times width. So the length will be 0.5 and the width will be this one. Right? So basically the width will be f of 1.5. Okay, in another way to say it is will be f of 1.5. So area of the blue rectangle, and I use the color code for you guys so you guys can follow it easier. So area of blue rectangle will be length times width, and I have 0.5 times f of 1.5. Okay, actually I should move it up here so we have more space later. Okay. So that means I will plug 1.5 into the f of x. So then I have f of 1.5 is 2.25 and 0.5 times 2.25. So equals 0.5, and this one, now I can do it as 1.5 squared. So I'm using the function of f of x, and then that could give me 2.25. Oh, I didn't times 0.5 yet. And then multiply by 0.5, so it's give me 1.125. Okay. Right, do the same thing for the green rectangle. I have area of green rectangle, and the width is still 0.5. Okay, so I'm using the width right here, and the width is still 0.5. So 0.5, and then the length will be the length right here. So that means I'm using f of 2. So f of 2. So then I have 0.5, and f of 2 will become 2 squared. And that gives me 1. And so on. Now I have area of red rectangle will be 0.5. The width is still 0.5, but the length right now will be f of 2.5. For those of you who got this, you got it right. And then we have 0.5 times 2.5 squared. Let's give you 6.25, and then times 0.5, and you get 3.125. Okay, and then now next we do the same thing. Area of black rectangle will be 0.5 times f of 3, and then you get 0.5 times 9, 3 squared. I keep it that way so you guys can follow it easier. So 4.5. Okay, so then basically when you calculate the area under the curve with the right endpoint, that means you find the total of the area of the blue rectangle, green rectangle, red rectangle, and black rectangle add up together. So if we add all of them up, So we add all of these up. Okay, so add them up. We get the total of area of f of x. So of area under the curve, area under the curve using right endpoint is, okay, and then we can add them up. 1.125 plus 1 plus 3.125 plus 4.5. Total is 9.75, and I'll try to do it one more time. So always double check your calculation. 1.125 plus 1 plus 3.125 plus 4.5, 9.75. Yeah. So total is 9.75. Okay. Alright, that's one way to do it. Another way to do it is if we can use sigma notation to do this one. So how do we use sigma notation? I leave that part right there. And actually, before showing you guys sigma notation, I'll show you guys a short way to do this one too. So we know the sum is of them add up, but if you actually look at the work right here and you write all of them at once, so the total of area can be rewrite as 0.5 times f of 1.5 plus 0.5 times f of 2 plus 0.5 times f of, I keep making that mistake, 2.5 plus 0.5 times f of 3 will equals to the total of area. Okay, and what we notice is they all share 0.5, so that means we can factor out 0.5, and then we can have f of 1.5 plus f of 2 plus f of 2.5 plus f of 3. And we should get the same answer doing this way. Okay, so no matter which way you do, you can end up with the same answer as long as you do it right. Alright, so that's the short way of the long way on the right side right here. Now next, I will show you how to use sigma notation. So if you want to use sigma notation, you have to find the sum. However, we know that that sigma notation doesn't, the n in sigma notation have to be a whole number. Okay, but we cannot have decimal as the n. However, for the subinterval, we do have the n or the x value equal to 1.5 or 2.5 right here, which is not qualified to be n value. So how do we fix it? All right. So we go back here. So I call this one now is x0, x1, x2, x3, and x4. So you see that now I have subscription. So then I will write the equation for my subscription now by doing the table. So it maybe help you guys follow it easier. So if I do the table for this, I will call it the function of k and x of k. So my k, when my k equal to 0, which is right here, when my k is 0, so my x of 0 is 1. Okay. And then next, when my k equals 1, so when my k equals 1, my x sub 1 is 1.5. Okay. And so on. So when my k is 2, x sub 2 is 2. When my k is 3, x sub 3 is 2.5. And when my k is 4, x sub 4 is 3. Now I need to write the equation for this one. Okay. So then I assume you guys already know how to write the equation for linear function. So and this is we see it's just a constant rate of change. So then we can have x of k equals, and we add 0.5 every time, so the slope will be 0.5 k plus 1, because 1 is the starting value right here. Okay, so that means if your k equals 2, then you will have 0.5 times 2, which is 1, and plus 1 is 2. So x of 2 is 2. Another example, if you have x of 4, then your k is 4.5 times 4 is 2, plus 1 is 3, which is matched to your table. Okay, so that's the equation. And now we're back to this one. So then if we use sigma notation, because these are about the sum, so if we use sigma notation, we have sigma notation, and then we start with n equals. So now you have to look at this table, which one you use at the right endpoint. Did we use 1? No, we didn't use 1. We start from 1.5. And then we use 2, and we use 2.5, and we use 3. So therefore, your n, or your k, I should use k, is 1. Because you're using 1.5 as the starting point when you use the right endpoint. And then you stop at 4. Because the value you use as x is 3, but the k is 4. Okay? Sorry. And then for this one, you will have 0.5 times and you have 0.15k plus 1 square. Okay. Why is that? Because basically we just replace this one, the whole thing right here is the x value, and everything right here represent for f of x. So earlier we figured out that when we want to find the area under the curve, you have to find the sum. So sigma notation means the sum of the series. And we have, for the sum of all the rectangle, we come up with the formula. It will be the width, which is from 3 minus 1 divided by 4. So the width of each rectangle will be 0.5. So we have this number right here, matched to this. And then we know 0.5 times with whatever the height is. And the height come from the f of x value. Okay. So then you have, so basically this right here, we have 0.5 times f of x. And it can be x1, but we don't have just one x, but we have f of x1 plus f of x2 plus f of x3 and plus f of x4. So therefore the rule for this will be 0.5 times f of x, but f of x itself equal to x squared. However, we're using k right here, therefore x now replaced by 0.5k plus 1. Okay, so when you plug it into your calculator, you should get the same answer. So let's see. Sigma calculator. So I have n start with 1, and since this calculator use n as variable, it's the same as k, okay? And then up to 4, and then the rule is 0.5 times 0.5 n plus 1 everything square. Oh, I messed it up here. Okay, so we get 10.75, and I just recognize that I make mistake here. It should be 2 right here. Sorry guys, it should be 2 right here. So then this answer should be 10.75. Okay, so by doing different ways, you can recognize you make a mistake like I did. I did make a mistake on this very simple mistake. But then now I know that the answer should be the same no matter which way I do. Okay. Alright, so now we move on with the left endpoint. Alright, now we start with left endpoint. So we still have the interval from 1 through 3, but for left endpoint, we have to draw the rectangle. So the rectangle from 1 to 1.5, we cannot draw it above the line anymore, but because we use the left endpoint, so therefore the endpoint should touch the graph on this side. Okay, and then for your green rectangle, you have this. Then for red rectangle, you have this one. For black rectangle, you have okay, and by looking at the rectangle, you can expect the area of the left endpoint is smaller than the area of the right endpoint because it's under the curve. Alright, so we will do 2 ways, long way and short way. So we have, I calculate area of blue rectangle now. So for blue rectangle, I know the width for each rectangle is still 0.5. But then for blue rectangle, now the height or the length is not f of 1.5 anymore, but it will end as the value of f of 1. So therefore the area of blue rectangle will be 0.5 times f of 1. And then I have 0.5 times 1 square, so it's give me 0.5. Okay, same thing for green rectangle. I have the width is still 1.5, but the height will be the value of f of 1.5. So you have f of 1.5, and I already did it for the other one, so it just bring in the answer here, which is 1.125. Okay, and keep going. My red rectangle, area of red rectangle will be 0.5, and the value for the length will be the value of f of 2. So then I have 2. Okay. And the next area of black rectangle will be 0.5 times, and the value for the length will be f of 2.5. So times f of 2.5, and I already got it earlier, so it's 3.125. So now I have to find the total of these, and that means the area of these add up the area under the curve. Okay, so now I add all of them up. So this is the area, total area under the curve using left endpoint. Okay, I will be careful with my calculation this time. So now I have 0.5 plus 1.125 plus 2 plus 3.125. It's give me 6.75. Alright, do it one more time to make sure. So 0.5 plus 1.125 plus 2 plus 3.125. Yeah, 6.75. And like I said, we can do the short way by we have 0.5 f of 1 plus 0.5 times f of 1.5 plus 0.5 f of 2 plus 0.5 f of 2.5. Okay, and it's also give you the total area. But similar to the left endpoint, we know that it's similar, so we have 0.5 outside, and then inside we can have f of 1 plus f of 1.5 plus f of 2 plus f of 2.5. Alright. Okay, so then based on this, I can come up with the rule, which is 0.5 times f of x okay, but the x will be from the interval of 1 and 3. But because I want to add the sum, okay, so f of x is just one value, but I want to add the sum, therefore I will put the sigma notation here in front. Alright. However, for my x value, I do have 1.5 and 2.5 as the value that I cannot put it as the k term or the n term for the sigma notation, because when we count in the term, we have to use only whole number. So then the other way to do it, in order to use sigma notation, make it work for this problem, I have to convert this value into something that whole number, and go back here. That's how I convert it. So right here, my x value is 1, 1.5, 2, 2.5, and 3. And I just write another sub-equation. So I can write 1 as x of 0. I can write 1.5 as x of 1. I can write 2 as x of 2. 1 is 0 term, 1.5 is my first term, 2 is my second term, 2.5 is my third term, and 3 is my fourth term. And then I will write the equation for this. So for this problem, I already have x of k, so I will use it. So then x of k equals 0.5k plus 1. So then from here, I will convert it to sigma notation 0.5, and f of x, the function will be x squared. Alright? However, I cannot use the value of x because I have 1.5 and 2.5 at decimal. So therefore, I need to use only whole number. So then that's why I will convert it as 0.5, and then x, I replace x by x of k. Sorry, my equation is 0.5k plus 1 and then square, because the whole thing right here equivalent to my x. And by using k, it allows me to use the whole number. So then for this, I will have my x, and because my first term right here is f of 1, okay, f of 1, I go back up here, my f of 1 equivalent to the k equals 0. So basically I use k equals 0 to 3. Okay. And then now I'll use the calculator. So we have this. We just need to fix this. Become 0. This become 3. Everything should be the same. Yeah, got the same answer. 6.75 as the sum. Alright, so I hope you guys, this video helped you guys understand a little bit more about how to use sigma notation, or how to find the sum of the rectangle under the curve, also known as how to calculate the area under the curve or above the curve using right endpoints and left endpoints.